வணக்கம். This is Babu from TPDE Bangalore. Unit 4 Fourier Transform Part 2. Let us recall Fourier transform formulas. The Fourier of f of x equal to 1 divided by square root of 2 pi integration minus infinity plus infinity f of x e power isx dx. Its inversion formula is just interchange this and this. So f of x equal to 1 divided by square root of 2 pi minus infinity plus infinity Fourier of f of x. So instead of plus isx, so replace minus isx. Here integrating with respect to x, here integrating with respect to s only, then only we get the answer in terms of x. Next, partial identity formula. Minus infinity plus infinity modulus f of x the whole square dx equal to integration minus infinity plus infinity Fourier of f of x whole square into dx. Problems. Problem number 2. Find the Fourier transform of f of x equal to 1 minus mod x when mod x less than 1, 0 when mod x greater than or equal to 1. Using this result, deduce that first one 0 to infinity sin t by t whole square dt equal to pi by 2. Next result 0 to infinity sin t divided by t whole power 4 dt equal to pi by 3. So for reduction, we have to apply either inversion formula or partial identity. So if the reduction is similar to Fourier of f of x, then we have to apply inversion formula. If the reduction is similar to Fourier of f of x, the whole square, then we have to apply partial identity. First, we need to find the Fourier transform of f of x. So what is the formula for Fourier transform of f of x? Fourier transform of f of x equal to 1 divided by square root of 2 pi integration minus infinity plus infinity f of x e power isx into dx. So what is f of x? So actually the limit minus infinity to plus infinity is split into three parts as minus infinity to minus 1, minus 1 to plus 1 and 1 to infinity. So this minus 1 to plus 1 is called mod x less than 1 part. In mod x less than 1, f of x is given as 1 minus mod x. In mod x less than 1, f of x is given as 1 minus mod x. Other two parts, namely minus infinity to minus 1 and 1 to infinity, they together is called mod x greater than or equal to 1. This is mod x greater than or equal to 1 and mod x greater than or equal to 1. In that parts, f of x is given as 0. Thus, f of x is defined in minus 1 to plus only, plus 1 only. Therefore, we take minus infinity plus infinity as minus 1 to plus 1. So, 1 divided by square root of 2 pi. So, minus 1 to plus 1, minus 1 to plus 1. In minus 1 to plus 1, what is f of x? In minus 1 to plus 1, f of x equal to 1 minus mod x. This is 1 minus mod x. Next, what is e power I sx cos sx plus I sin sx into dx. Next, split this term into two parts, namely this into this and this into this. So which is equal to 1 divided by square root of 2 pi minus 1 to plus 1, 1 minus mod x into cos x plus integration minus 1 to plus 1, 1 minus mod x into I sin sx into dx. So this is an even function because mod x is an even function and a cosine is also an even function. So even and even, it is an even function. Therefore, in even function, this can be written as 2 times 0 to 1. Next, this is an even function, but sine is an odd function. So even into odd is an odd function. So in odd function, for odd function, the value of integration minus 1 to plus 1 is 0. So which is equal to 1 divided by square root of 2 pi. So this is an even function, therefore it can be written as 2 times 0 to 1. So it is an odd function, therefore that value equal to 0. So next. So 0 to 1 is a positive limit. 0 to 1 is a positive limit. In positive limit, mod x equal to plus x. Mod x equal to x only. Therefore, we take mod x equal to x because 0 to 1 is a positive limit. So 1 divided by square root of 2 pi 2 times 0 to 1 1 minus x cos x dx because so 0 to 1 is a positive limit. In positive limit, mod x equal to x. Next, apply UDV formula. So take u equal to 1 minus x and dv as cos sx into dx. So apply the Bernoulli formula, 2 divided by square root of 2 pi. So write u as it is, don't differentiate and don't integrate, as it is. Write u as it is, 1 minus x. Next integrate the second term with respect to x. So integration of cosine sx equal to sine sx divided by s. Next alternate term minus, to differentiate the blue bracketed term and integrate the black bracketed term. That is, so we have to differentiate the first term. Next we have to integrate the second term. So alternate term, the differentiation of this one equal to minus 1. Integration of this one equal to minus cos sx divided by s into again 1s. Next alternate sign minus plus. So differentiate the blue bracketed term. So differentiation of minus 1 is 0. Hereafter all terms are vanished. So we stop the process. Apply the limit x equal to 0 to 1, which is equal to 2 divided by square root of 2 pi. Apply the upper limit x equal to 1. So here x equal to 1, here x equal to 1, here x equal to 1. So this is 1, sin s into 1, sin s, cos s into 1, cos x. This is upper limit minus lower limit. So lower limit we have to substitute x equal to 0. So this is 0, this is sin 0, this is cos 0, which is equal to 2 divided by square root of 2 pi. 1 minus 1 is 0. So 0 into anything is 0. Next, minus into minus into minus, minus cos s divided by s square. Next, sin 0 is 0, sin 0 is 0, 0 into anything is 0. This is minus into minus into minus, minus cos 0 value is 1, cos 0 equal to 1, 1 divided by s square. Here minus into minus plus 1 divided by s square. Here minus cos s divided by s square. So s square is common. So numerator is 1 minus cos x. So first write the positive term, minus into minus plus. So 1 minus cos x divided by s square. But the deduction in terms of sign only. So therefore we need the Fourier transform in terms of sign only. Therefore, we have to convert this 1 minus cos s as sine. So, we know that 1 minus cos s equal to 2 times sine s square s by 2. So, substitute, since 1 minus cos s equal to 2 sine square s by 2. So, substitute here. So, 2 divided by square root of 2 by 2 sine square s by 2 divided by s square. So, which can be written as 2 into 2, 4, square root of 2 pi sin s by 2 divided by s the whole square. So, this is the first part of this problem. So, take this as equation number 1. Next, deduction of 1. We have to prove 0 to infinity sin t by t whole square dt equal to 5 by 2. So note that sin t by t the whole square is similar to sin s by t divided by s the whole square. That is, this deduction is similar to Fourier of f of x. Therefore, we have to apply inversion formula. So by inversion formula, f of x equal to 1 divided by square root of 2 pi integration minus infinity plus infinity Fourier of f of x e power minus isx into ds. So substitute f of x, which is given in the problem, that is 1 minus mod x, and substitute Fourier of f of x, which is given in equation 1, this value. This implies 1 minus mod x equal to 1 divided by square root of 2 pi. F of x is given in the problem as 1 minus mod x, which is equal to 1 divided by square root of 2 pi. Integration minus infinity plus infinity. So this is from equation 1. We have minus infinity plus infinity 4 divided by square root of 2 pi sin x by 2 divided by s the whole square into e power minus isx into ds. Compare this with this term, comparing with the deduction 1. So your numerator is sin t, your numerator is sin s by 2. So therefore substitute s equal to 2t, then only s 2 get cancelled, we have t. So put s equal to 2t. When s equal to 2t, 2 can cancel, we have sin t. Okay. Next, so we don't need this term. We don't need this term. Therefore, put x equal to 0, then this term becomes 1 because anything power 0 is 1. We don't need this term. Substitute x equal to 0. Anything power 0 is 1. So x equal to 0. So when s equal to 2t, so we need ds. So differentiating on both sides, we get ds equal to 2 dt. So ds equal to 2 dt. So substituting, so these three values in this term, we have 1 minus modulus 0 because x equal to 0, 1 minus modulus 0, which is equal to 4 divided by 2 pi integration minus infinity plus infinity. When s equal to 2t, when s equal to 2t, this is 2t by 2, s equal to 2t, this is 2t, anything power 0 because x equal to 0, this is e power 0, the ds equal to 2 dt. This implies 1 equal to 4 divided by 2 pi. So this 2 we can take outside. Next 2 square we can take outside. Thus 2 divided by 2 square into, so for reduction we need 0 to infinity, here minus into plus infinity. So note that it is an even function because it is a squaring term, it is an even function. Therefore minus into plus infinity can be written as 2 times 0 to infinity. So here 2 get cancelled, so this is sin t, this is sin t. So 2, so we have taken 2 outside, therefore this is t only. So sin t by t whole square into dt. So we need this term only. So 0 to infinity sin t by t whole square dt. So now, so 4 into 2, so this 4, this 2 square get cancelled and this 2 get cancelled. So this is 2 by pi. Scalar 1 equal to 2 pi pi 0 to infinity. So now bring this term into left hand side. We have pi by 2. So it implies pi by 2 equal to 0 to infinity sin t by t whole square dt. So this proves 1. This proves 1. Next, direction of 2. We need to prove 0 to infinity sin t by t whole power 4 dt equal to pi by 3. Here power is 4. So Fourier of f of x is power is square. So the direction of 2 is similar to Fourier of f of x the whole square. Then only we get power 4. Fourier of f of x the whole square. So therefore, this term is similar to Fourier of f of x the whole square. Therefore, we have to apply Parseval's identity. So by Parseval's identity, what is the formula for Parseval identity? Integration minus infinity plus infinity modulus f of x whole square dx equal to the same term right hand side. So instead of f of x, we put Fourier of f of x and integrate with respect to s only. So integration minus infinity plus infinity Fourier of f of x whole square into ds. Now substitute this f of x. So we know f of x equal to what? 1 minus mod x, which is given in the problem. Also 1 minus mod x is defined in what limits, in which limits they are, which is given in minus 1 to plus 1. Therefore we change minus infinity to plus infinity as minus 1 to plus 1. F of x equal to 1 minus mod x the whole square into dx. So 1 minus mod x is a real function, therefore we remove modulus, which is equal to integration minus infinity plus infinity, which is given in equation 1, which is given in equation 1. So integration minus infinity plus infinity 4 divided by square root of 2 pi sin s by t divided by s the whole square into ds by equation 1. So this implies, so squaring is an even function, therefore we can write minus 1 to plus 1 as 2 times 0 to 1, 1 minus x whole square into dx. Here also squaring is an even function. Also 4 square, so 4 divided by square root of 2 pi the whole square, 4 divided by square root of 2 pi the whole square. It is a constant term, therefore we take outside. So minus squaring term is an even function, therefore minus into plus unity can be written as 2 times 0 to infinity sin s by t divided by s. 2 into 2 equal to 4 into ds. So this implies 2 into 0 to 1, a minus b whole square formula, a square minus 2ab plus b square into dx. So 4 square is 16, square root of 2 pi whole square is 2 pi, and 2 get cancelled, which is 5, 0 to infinity sin s by t divided by s whole power 4 into ds. Compare with this deduction of 3, compare this with deduction of 3, that is this, compare this with deduction of 3. Here numerator is sin t, here numerator is sin of s by 2. So put s equal to 2t, then only 2 get cancelled, we have sin t. So put s equal to 2t. So this implies, so here also ds, so this implies differentiating on both sides, this implies ds equal to 2 dt. So substituting s equal to 2t, s equal to 2t, ds equal to 2 dt, we get this one. So now 2 get cancelled. So this implies 2 times. Now integrate this one. The integration of 1 is x. Integration of x is x square by 2. Integration of x square is x square by x cube by 3. Apply the limit 0 to 1, which is equal to 16 by 5. So here 2 is a constant. So we take outside. Next 2 power 4 is constant. So we take outside, which is equal to 0 to infinity sin t divided by t whole power 4 into dt. So this is what we required. This is what we required. So this implies limit 2 times 1 minus 2 by 2 plus 1 by 3. When x equal to 1, this is 1, this is 1, this is 1, 1 minus 2 by 2 plus 1 by 3, which is equal to, so 16, 16 get cancelled, which is equal to 2 pi 0 to infinity sin t by t whole power 4 dt. This implies, so after taking LCM, this is 2 by 3. So we bring pi by 2 into this side. So we get pi by 2. So equal to 0 to infinity sin t by t whole power 4 dt. So now 2 get cancelled. So therefore the answer is pi by 3, which is what we required. This is pi by 3. So this proves 2. Hence the problem. Problem number 3. Find the Fourier transform of f of x equal to 1 when mod x less than 1, 0 when mod x greater than or equal to a. Hence, deduce that 0 to infinity sin t by t dt equal to pi by 2, 0 to infinity sin t by t whole square dt equal to pi by 2. So first we need to find the Fourier transform of f of x. What is the formula for Fourier of f of x? 1 divided by square root of 2 pi integration minus into plus unity f of x e power isx into dx. F of x, actually the limit minus into plus unity splitted into 3 parts, namely minus into 2, sorry here minus a, this is plus a. So minus infinity to minus a to plus a to infinity. So minus a to plus a is called mod x less than a, is called mod x less than a. So in mod x less than a, f of x equal to 1, f of x equal to 1. Another two parts, minus infinity to minus a and a to infinity, together is called mod x greater than or equal to a. That is minus to minus a is mod x greater than or equal to a, and a to infinity is also mod x greater than or equal to a. So in those limits, f of x is given as 0. F of x is given as 0. Therefore, we take the limit minus infinity to plus infinity as minus a to plus a, because in this limit only f of x is non-zero. So thus 1 divided by square root of 2 pi integration minus a to plus a. In minus a to plus a, f of x equal to what? 1. So 1 into e power ixx equal to cos sx plus I sin sx into dx. Next, this into this and this into this is equal to minus a2 plus a cos sx dx plus minus a2 plus a I sin sx into dx. So this is an even function, this is an odd function. So for even function, minus a2 plus a can be written as 2 times 0 to a. So for odd function, this value equal to 0. So now integrate. Integration of cos sx is sin sx divided by s. The limit is x equal to 0 to a. Apply the limit sin sa divided by s minus sin 0 divided by s. The value of sin 0 is 0. So this is 0 because sin 0 value is 0. So the answer is Fourier of f of x equal to 2 divided by square root of 2 pi sin sa divided by s. So take this as equation number 1. Deduction of 1. So we have to deduce 0 to infinity sin t divided by t dt equal to pi by 2. So note that sin t by t is similar to sin sa divided by s, that is which is similar to Fourier of f of x. Therefore we have to apply inversion formula. So by inversion formula, f of x equal to 1 divided by square root of 2 pi minus infinity 2 plus infinity Fourier of f of x e power minus isx into dx. Now substitute what is f of x? F of x equal to 1, which is given in the problem. Next substitute this, which is given in equation 1. So 1 equal to 1 divided by square root of 2 pi integration minus into plus infinity 2 divided by square root of 2 pi sin s divided by s e power minus isx into ds. This implies 1 equal to, so 2 into 1 is 2 square root of 2 pi into square root of 2 pi minus infinity plus infinity sin s divided by s into e power minus isx into dx. This 1 equal to 2 get cancelled, 1 by pi integration minus infinity plus infinity sin s divided by s e power minus isx into dx. So now compare this with this one, the red one. So comparing with the deduction 1. So here numerator is sin SA, here numerator is sin T. So substitute S equal to T and A equal to 1, we get sin T. So sin T by T, so we have sin T by T. The next we remove this term. So how to remove this term? By substituting x equal to 0, because anything above 0 is 1. So substitute S equal to T, A equal to 1 and x equal to 0. So put s equal to t, a equal to 1 and x equal to 0. We get 1 equal to 1 by pi integration minus infinity plus infinity sin t by t. Sorry, this one is t. Anything above 0 is 1 into ds, so dt. So this implies 1 equal to 1 by pi. So but we need the limit 0 to infinity. So this is an even function. Sin t by t is an even function because sin of minus t equal to minus sin t. Here minus t, so minus minus get cancelled. So it is an even function. So for even function, minus infinity plus infinity can be taken as 0 to infinity. So 2 times 0 to infinity sin t by t dt. So this implies this is 2 by pi. Bring this into left hand side. We have reciprocal, that is pi by 2. So this implies pi by 2 equal to 0 to infinity sin t by t dt. So this proves 1. Next deduction of 2. Sin t by t whole square dt equal to pi by 2. So note that this is similar to Fourier of f of x the whole square. Therefore we have to apply Parseval's theorem. So by Parseval's identity, what is Parseval's identity? Integration minus infinity plus infinity modulus f of x whole square dx equal to minus infinity plus infinity Fourier of f of x whole square into ds. So note that here f of x and Fourier of f of x are real functions. Therefore we remove modulus. So this implies, so what is f of x? F of x given as 1 in which limits minus 1 minus a to plus a. Therefore it is written as minus a to plus a 1 square into dx, which is equal to which is given in equation 1. So we can use equation 1, which is given in equation 1. So integration minus infinity plus infinity 2 divided by square root of 2 pi sin s divided by s the whole square into ds. This implies, so it is an even function. So constant functions are always an even function. Therefore it can be written as 2 times 0 to a dx. So it is also an even function. Therefore it can be written also 2 times 0 to infinity. Before that, take 2 by square root of 2 pi, the whole square is constant outside. So 2 square is 4, square root of 2 pi whole square is 2 pi. So it is an even function, therefore minus into plus infinity can be written as 2 times 0 to infinity sin sa divided by s the whole square into ds. So this implies after integrating we have a equal to, now 2 to get cancelled, so this is 4 divided by pi sin sa divided by s the whole square into ds. Compare this with the direction of 3, that is this red one with this red one. A numerator is sin t, a numerator is sin sa. Therefore, substitute s equal to t and a equal to 1. So, put s equal to t and a equal to 1, we get, so 2 into 1 which is equal to 4 by 5 integration 0 to infinity sin t by t whole square into dt. So, this implies, so 2 pi divided by 4, that is pi by 2, 0 to infinity sin t by whole square into dt. So this proves 2, this proves 2, hence proved. So try yourself. Find the Fourier transform of f of x equal to 1 minus x square mod x less than 1, 0 when mod x greater than or equal to 1. There are 3 detections are given. Fifth problem, find the Fourier transform of f of x equal to a minus mod x when mod x less than a, 0 when mod x greater than or equal to a. There are 2 detections are given. So note that problem number 4 is similar to problem 1 of previous video lecture, and this problem is similar to problem number 2 of this video lecture. These 5 problems are very important. Normally, we can expect 160 marks or at least 18 marks in Anna University examinations. Study well. All the best.